Hey guys, let's get started. Okay, welcome back. If you guys want to follow along with today's material, again, I'm doing this in a notebook, so all the code and everything is there so you can run it yourself. Just go on the course website, and you'll be able to see, in the slides link, you'll see a link to today's slides, well, to the notebook. And there's some code as well that I put on my courses. You don't have to do it now, but if you want, it's just a folder that you download. It actually includes the notebook, it includes everything, so you can just put it in your computer, and all the code that's not in the notebook but that we'll still be using is going to be in there if you want to test it out. So yeah, it's just on my courses under content. Yeah. Okay. So today we're going to wrap up our discussion on basics of how types and objects work. Do a little recap, and then we're going to go into modules and packages. So what's going on when you say import something, right? That's basically the idea of today. So I don't know if we'll get through all of it, but we'll do our best. Okay. So recap of last lecture. Basically, as I've been repeating ad nauseum, every piece of data in Python is what we call an object. So just imagine like a shelf in a box. A shelf on a bookshelf, and you can stick information in there, and it'll have some type, right? So we have integers, strings, tuples, all this stuff are just types of objects, okay? And we saw also now that these types, can be described as a tree or a hierarchy. So just as if you were to look at the world and describe how everything works and all the relationships between things, you would say, okay, well maybe we have some sort of hierarchy where the most general type, we can call it an object, right? And then you can subdivide that into, animate objects and inanimate objects, and you can keep going that until you can categorize everything in the world, right? So in Python, we have a similar idea, right? I'm just going to pull up that picture again because it's good to keep it in mind. So it was here, right? So if we look at the world, maybe you can have some sort of classification like this, right? Everything is an object. And objects can be non-living objects and living objects, and that would mean that this, for example, subcategory has all the properties of object, but it has some other on its own, right? That distinguish it, and you can go all the way down to tree. So a tree is a plant, which is a type of life form, which is a living object, and so on. In Python, they mimic the same thing, right? Except the most general type is called object, right? And then from there, you can subcategorize. So, for example, lists are a type of object. Whenever you make a new class yourself, unless you specify otherwise, you're kind of becoming a descendant of the object class. So you'll have all the properties of a general object and whatever you define yourself. Okay? So we saw that this was kind of the most basic way to define a class. You use the statement class, and then you give your class a name. In Python, the style for defining a class is usually what's called camel case. So the first letter of each word is capitalized. I guess it makes it look like a camel because it's bumpy. So that's how you define a class. And if you want, you just do nothing. Say pass. And you define a class. And now you can create objects of that class. Okay? Obviously, this is not very interesting. What's happening here is actually Python says, all right, well, you didn't really define anything to differentiate yourself. So I'm just going to take whatever your parent class does to create a new object and use it for you, right? But if we want to make our class a little more unique, we can give it our own initialization function, right? We said that the __ new function creates an object, and then after that object's created, that gets passed to this init function, right? And all it does is it gets called every time an object is created, right? So here we're creating an object. So what's happening is the new function gets called, and then the init function gets called. In this class animal, because we've defined our own init function, Python says, okay, I'll use this one instead of your ancestor. And all it's doing is it's saying, okay, well, the current object is going to have this attribute number of legs, and it's going to set it to whatever the person that is running this function gives me as arguments, right? And furry is another one, so this can be true or false, and this will be some integer, okay? So these would be something that's called instance attributes, right? Because whenever you create an instance of this class, just how individuals or instances of the class people. You can imagine it that way. For example, every time I create an object of the class animal, it's going to be an instance of it. So every instance is going to have its own value for this attribute. And instances of a class can also share some data as well. So if you define a variable at the level of the class, so not inside of a function, you could say every instance of this class is going to have the same value for that attribute. Okay? And here we're just keeping track of how many animals we create. So every time inside the initialization function, every time I create an object, I say the name of my class, dot animal count, and I'll increment it by 1. So every time a new object gets created, this count is going to go up by 1. And it's not like every animal has a different count for how many animals there are in the class. No, there's just one class, and that class has one constant number of animals. Not constant, but shared. You can also define methods that objects can do. So when a method is defined inside of a class, when a function is defined inside of a class, it's called a method. And specifically, it's an instance method because it takes in an instance of the class, self, here, right? And then it does stuff with it, right? So for example, here we're going to make the animal sound, right? So for example, this checks if the object that you pass to me has the attribute furry equal to true, then, I don't know, we imagine it's a dog and it barks, okay? Otherwise, we print moo, okay? So this function, better known now as a method, acts on instances of the class. So if we go down here and we say, all right, we're going to define have a new name and give it an object, and the object is going to be this new animal object that we're creating. So the way you create an object, remember, is the name of the class, and then you call it as though it were a function. So you give it round brackets, and you give it whatever arguments it needs. So if you look at the initialization function, it requires a number of legs and whether or not it's furry. The self here gets passed implicitly, so it actually comes from whatever is before the dot. Okay? So that's something that's a little bit weird, but you basically assume that this first input is actually the object that is calling the function. All right? So you can say dog.makeSound. That means I've created an object of type type animal, and it has this attribute make sound. Right? When you say dot, you're accessing an attribute, and it doesn't take arguments other than the dog itself, right? Which goes up here. And then the function just does something, right? So this particular instance of the class animal has 4 legs and is going to have a true in the furry attribute, all right? So when we check this, this is going to evaluate the true, and hopefully it's going to print woof, okay? I can do the same thing for another animal, right? But say this animal is not exactly the same as the other one, so this one's not furry. And then if we were to call its make sound function, we would get something different, right? So the first object did woof woof, and the second one did moo. All right. So basically, objects let us kind of create similar things, but that have different parameters, you can say, right? So animals all belong to the same category, but they might have different, particularities, right? So for example, dogs are furrier than cows, so we can keep track of that easily using object-oriented programming. Any questions? Yes?
What does it mean by animal dot make sound?
Right, so animal is the name of our class, right? So I'm saying I want my class, and I want an attribute of the class. So anything that's defined at the class level, which would be this, for example, I can access it, and I can set its value to something. So it's accessing a class attribute instead of an instance attribute. You see the difference? So an instance attribute is one that acts on an instance of the class, so a particular animal. And a class attribute is something that acts on the entire class. So the animal count is something that belongs to the entire class. So you're saying class name dot class attribute, right? Here is instance dot instance attribute. Okay? So what the dot operator is doing is just accessing the namespace of an object. So the syntax is, some object dot some attribute of the object, okay? And it turns out that objects basically define their own namespace, right? Kind of like functions, as clearly, these two objects, right, have the same variable, right? I can say, you know, print dog dot leg, number of legs, right? That's kind of the same name, right? Number of legs, and this one, right? They both have the same name, but those two will have different values. So that tells us that they're different namespaces, right? So they're kind of independent. And the way it works in Python is actually namespaces are just dictionaries, all right? Where you map the name of a Python name to an object, right? Just how dictionaries map keys to values, you just map a name to an object. So any class that you create, and if you create an instance of that class, they're all going to have an attribute called _ dict, okay? And that dictionary represents all the attributes of that instance, all right? And if we print them out, if we print the dogs dictionary and the cows dictionary and the classes dictionary, we should see different things because they're different namespaces, okay? So we see that the dog has this name attached to this object, right, 4, and this name attached to this object, right? So the names can be the same, but the values can be different, right? Because they're different namespaces. So this is the cow and this is the dog. And these are the attributes of our animal class, okay? So animals are actually, classes are actually just objects, so they have attributes as well. And for example, here we have this class level attribute called animal count, okay? This is just kind of behind the scenes stuff. You don't have to worry about it too much. So basically what the dot notation is kind of like a shorthand for accessing this dictionary, okay? So when you have an instance, you can access its namespace dictionary, and you can look up a key inside that dictionary, and you can set it to whatever value you like, right? So if I want to chop off a leg from this dog, now it has 3 legs, I can go into the dictionary and set the number of legs attribute to 3 now, right? And that would be the same thing as doing this, dog dot number of legs equals 4. Okay, so it's just like a shorthand for the same thing, for accessing this dictionary. And actually, I'm still using the dot operator here. So if I really wanted to show you what's going on with the dot operator, I would have to call this built-in function called get attribute, right? Shortened to get attr, where you would give it an instance of your class and an attribute that you want to access, and it would fetch it for you. Okay, so this is like way longer than just saying dog dot number of legs. Okay, but all I'm saying is it's all just dictionaries in the background. Okay, we're just making things simpler. And obviously, if you have objects can have attributes that are also objects. So you can kind of go down using the dot multiple times, right? So for example, the dog object has an attribute number of legs, which is an integer, so that also has an attribute called denominator. So you can use dot dot dot, as appropriate. All right? You'll get lots of practice with this in the assignment. Any questions with that? So basically, you can create your own types, and it's just setting some attributes for some objects, and then, yes?
So, it seems like the way you describe it is just a series of dictionaries, one to another, one to another. So what is the advantage of using objects in programming rather than just creating a number of dictionaries or a number of tuples?
It's just cleaner. You can do the same thing, like you can be using dictionaries directly, and your code will work exactly the same. It'll just be messier to deal with, basically. Yeah. At the end of the day, this is all just dictionaries, right? So Python's kind of taking care of the mess for you and letting you define your data types and organizing them neatly instead of having to do like something like this, right? This would be like the way it would work with dictionaries. So yeah, it's just for convenience. So objects are not mandatory. It's just a way of organizing your data. But at the end of the day, it's all just integers and strings and dictionaries and for loops, right? It's all, from now on, there's no new concepts, right? It's really just making things more convenient. So that's all I wanted to say about that. And now I think this is going to be a little bit simpler. So basically, we're going to look at what happens when you import some code into your Python script, okay? So basically, we're going to look at what's a module, what happens when you import, how you can make your own modules that can get imported, and how to install other people's packages and modules, okay? So the whole idea about this is that, if you write something that's useful, it only becomes useful when other people can use it too, right? I mean, unless, it's super specific, but generally, if you have something that can be used by other people, you want to be able to share it really easily. And you don't want everybody to have to reinvent the wheel from scratch, right? That's the whole idea of programming. So we've already looked at this, right? For example, the plotting stuff, right? Somebody had to go and type out all the code that lets you plot something, right? If we want to plot something, we don't have to rewrite all that. We can just, pull it into our code and then use it, all right? So basically, any single .py file that contains some valid Python code is what we call a module, okay? That's just a word. So a module is just a .py file, all right? A lot of people misuse this term. They say I'm downloading a package, a module. A Python file is a module, okay? And you can, include them in your own code or not, right? So you can they're sort of like, they're called modules because they're modular, okay? You can take one and slap it into another one, okay? For example, we've been using the map.lib module, okay? Actually, it's a package, but I'll go into that later. So the key thing that we want to look at here is the import statement, and we've already worked with it a little bit. Basically, import lets you include another Python file in yours, okay, so that you can use any code that's defined inside of it. So if I wanted to create my own module, let's do that, all right? Basically, Python says, okay, when you say import something, for example, we're going to import here the OS module, which is in the standard library, so you don't have to install it. Python is there for you when you download Python. And basically, this one lets you do stuff with the operating system. Anyway, the point is, Python says, okay, you want to import this thing called OS. Well, all it is just some file that contains some Python, so I have to look for it in your computer in order to execute it. So it just has to go on and look for it, right? And basically, what we're going to have to do is recap a little bit how files work in your computer. But basically, the reason I wanted to import this OS module is because it tells you what folder in your computer you're currently in, okay? So if you call the attribute getCWD, so that stands for get current working directory, it'll print out the path to where I am right now in my computer, okay? So right now I'm in users, Carlos, documents, courses, COM264, slides, lecture 23, okay? So that's where I'm executing Python from. And the way this looks is like a tree, all right? A lot of things in computer science are trees, so it's good to get used to them. And basically, this list of directories is kind of like a path along this tree, all right? So you start at the root, at the top, and then every time you take a step separated by a slash, you're going into a subdirectory, right? So imagine, this is root, then this is root, users, documents, whatever, and then my Python file, okay? So it just looks like a tree, that's it. So when you say import something, Python says, all right, well, right now, we're down here. So I'm gonna look for, let's say, OS. I'm gonna look for a file called os.py where I currently am, okay? If I don't find it, I'm gonna go up and look for it somewhere else in your computer, okay? So let's actually try that out. So because we're in a notebook, obviously Python, a notebook is not really a Python file. It's kind of like this weird mix of HTML and Python. So I'm gonna work with separate Python files elsewhere. So you can use your Sublime. Okay, let's use Sublime here. Okay. So I already wrote a module for us that we're going to be playing with. And it's going to be inside courses, COM364, slides, lecture 23, and it's called myplot.py. Okay? So we're going to write our own little module that helps us plot things more conveniently. Okay? And hopefully you'll never use Excel again after this. So this is just a Python file. Okay? It does some stuff. It imports matplotlib, and it defines a function that all it does is it takes in some list of values and it'll plot them for you. Okay? It has some optional arguments if you want your plot to have a title or X label, Y label. It'll add them if if the user passes them. Otherwise, it'll still generate a plot for you. So it's a nice example. I use keyword arguments here a lot because sometimes you want to add a label, sometimes you don't. If you have a function that can handle both cases, then it's a lot easier for you, okay? And then it does this. It just says print hello from my plot, okay? So that's just a Python file that I've placed where I'm executing Python from. So it would be in this directory, okay? And so I should be able now to just say import my plot, okay? Because I called this file myplot.py, I just say import my plot. Okay, it imported it. So that's good. Now I can use a function that I defined in it, right? You can imagine that it's an instance of a class, and you can use the dot operator to access its attributes, right? So you can say myplot, which is the name of the module, dot line plot, which is this function that I defined over here, right? And then I can just give it, I just use the list comprehension to generate a list of points, and it made the plot for me, okay? Is that clear? Yes?
What if you want to import your Y and your X
Yeah, you can do that. So,
file? You have like a empty, like a text file.
mm-hmm. Import a text file.
Or like how would you do that?
If I wanted to plot like something from a file, you're saying?
Yeah.
Some data from a file? Well, then I would just like open the file, right? Right? And then whatever, And then I would just get the lines from the file, get the data from the file into some sort of list, right? And then I would call my function in the module. So usually, yeah. Is that fine? Yeah, so really when you're importing, obviously this is not always the case, but when you're importing and you're using stuff from other modules, it's usually functions that you're using. So it's like a functionality that you want to use, and then you can plug in your data. So you open a file, you import your thing, and then you plug the data into that function that you imported, okay? So that's nice. If you're going to be playing around with this, if you make any changes in your module, and then you save them, and then like you re-import, the changes you won't see the changes unless you restart your kernel. So you have to say kernel restart, and then you'll see the changes in your module. It's just a thing about notebooks. Okay. So what actually happened there was three things. So like I said, when you say import something, it looks for the module, so just a Python file that has that name, and it looks for it in a specific order, okay? And that order is given by this function, so I can import this other library called sys, and it has an attribute called path, right? So Python looks for this, and it says, all right, it's just a list of where to look for that Python file. So it goes first to this empty string, which stands for your current directory, like where you are right now. If it doesn't find it there, it looks for it in this location, in this location. If it's done looking for it and it doesn't find it, then it says you never defined this module, it doesn't exist, okay? So really it's just looking for a file in your computer along some order. All right, so that's the first thing it does. If it got that file successfully, then what it does is it creates a namespace for it. So it defines some attributes and some data for them, right? And then it says, okay, this is the code, I'm gonna execute it. It runs it, and then it gives you a name that you can now use where you are to access those attributes, right? So, for example, sys was just a .py file somewhere. It ran the code, and it gave me back a name, sys, okay? So sys is really just the name of an object, right? It has some ID, okay? And now this is a name that I can use to access attributes of that object, right? So it really behaves, yes?
How come, like for the assignment, like when you're doing a module, you said to input it in the same file as your notebook?
Same folder. Did I say file?
Folder. Oh, sorry, folder. But
Yeah.
Like, so it doesn't, like, you can't just have it like anywhere. Your computer has to be in a specific folder.
So it has to be either in the folder you're in right now, or in any of these other folders that are in the search path. So you could have put it like if you went on your computer and you did this sys.path, and you put it, I don't know, for example, in this folder, it would work. Okay, it just has to be in any of these folders in this list. Yeah, and if you wanted to add a folder, you could say sys.path.append, you know, some path like documents. I don't know, if you wanted to look in your desktop, you would say something like this. And then now Python looks in the desktop as well. Let's see if that actually works. Yeah, see, so now now I've added desktop to where it looks for modules, right? I don't recommend you do this. It's just simpler to have it where you are, or in one of these default directories. Okay, so basically all you get is a name. Yes?
Just a quick question. This sys.path, this is something set inside your computer, right?
Yeah.
So, like, if you edit it, it'll edit for every single path search that occurs in your computer.
Yes.
Okay, so that's not
Not too much. I mean, you can always overwrite it and reset it, but yeah. Yeah. Typically, like, you don't have to play with this when you're installing stuff. I'll show you about that. But it's just how it works, okay? All right. So, like I said, modules are really just objects that have attributes, okay? So, for example, myplot, right, was that thing that we imported. It also has a dictionary of attributes, and it has an attribute called lineplot, which is the function that we defined. It has a type and it has an ID, right? So I printed the function, you know, the type that it is. So it's type class module. So it's a type from the class module, and it has an ID, right? So it really behaves the same as everything else. Yeah. So I don't know if you noticed, but let's do it again here. Let's import myplot again. Why didn't it do that? Oh, because I changed it. I have to restart my kernel. Sorry. Okay, so when I imported, I told you that Python executes all the code inside that file, right? And I had this like string that I printed in there that says hello from myplot, okay? Right here. Usually you don't want to have, when someone imports stuff, you don't want it to print a bunch of stuff and, like, you know, usually when you're debugging, you know that you put a bunch of print statements everywhere and you actually call your functions and they run, right? When you import all these other functions, all these other modules that I showed you, they don't actually print anything, right? So what's happening is the code is just storing some functions and they're not being executed, okay? The way you avoid that is this attribute that every module has, okay? Every module, which is just an object, has an attribute underscore underscore name, right? And if you're the first thing that Python runs, if you're the first module that Python runs, the value of your attribute name is going to be main, okay? It's this. If you're something that gets imported, your name attribute is going to be the name of the module, okay? So let's say I'm writing my module here and I'm debugging, so I need to know if I need to have this print statement, or I'll even like call my function, right, on some, you know, on some input just to see if it works, right? If someone's importing this, I don't want them to see all this stuff. So I'll just put in here, if my name, the attribute of the current module, is equal to main, then it's fine. I'll do this stuff because I'm calling this function, this module directly, right? But when this is actually being imported, this is going to have a different value. It's going to have the value myplot, right? So it actually won't do this stuff. Okay, so this is just good practice. So if you're writing a module that's going to get imported, anything that you don't want to execute when someone else imports it, you put it inside this if statement. All right. So now if I restart my kernel and I run it, I don't see that print statement anymore, and it's clean. I just have functions that I can call myself from here. All right. Another, yeah, so I'm just pasting in the code where I put the if statement here. So if you want to try it out. All right, just some little tips. If you're importing multiple modules, you can separate them by a comma. So here I'm importing the OS module and myplot module. and Python will import them so you don't have to have a bunch of lines. I think usually it's good style to not do this, but it doesn't matter, it's up to you. Now let's say you're tired of every time you access a function from your module, you have to say, module name dot function name, right? Because you're accessing an attribute from an object. So if your module name is really long and it's annoying to type it out every time, I already showed you this, you can give it a nickname, right? So instead of giving it the name myplot when it gets imported, it gives it this nickname. So now you can say mp.lineplot, and it's just shorter for you, okay? So you're using the as keyword here, and just changing the name that Python gives you for that module. And then sometimes you don't want to import everything that's defined in a module. So this module right now has only one function, but it could have had 50 functions, okay? And I might not necessarily need all of them, and I really only want to call one specific function. So I can say, I can use the from keyword. So I can say from this module myplot, only import the function lineplot, okay? And what that does is it puts that function directly in your current namespace, all right? So you don't have to use the dot anymore. You can just, it's as though it was defined by you in your current module. And then it works, okay? So here I just plotted some random points using a list comprehension. I imported the random module. I used its attribute random, and I used it myplot, but I imported lineplot directly into my namespace. So now I can just say the name directly, okay? These are just shortcuts to make your life easier. If you want to be able to do this thing where you don't have to use the dot of the name of module dot something, you can say from your module, import star, and that imports every object from the module into your current module. So you can use all of the functions as though they were defined in your code. All right, so from here I took the math module and I imported everything, so all the functions defined in the math module. And from the NumPy module, I imported this function called arange. So now I can just directly call all these functions from their name without having to specify what module they belong to. All right, so see how that works? There you go. So if I hadn't done this, I would have had to say something like, myplot dot. So I have to specify what module to look in. And here I would have to say math dot. And here I would have to say numpy dot. Okay? So just little convenience hacks. Now, something to pay attention to. What happens if I want something from the math module? So I say from math import exp. What exp does is it does e to the power of something, okay? And what happens if I, in my own module, have a function with the same name, right? And it does something different. So you have two conflicting names here. And the general rule is that Python always, the local takes precedence over the global or whatever's distant, right? So the first thing it sees is, that you locally defined this function, so it'll actually use that over something from a different module, okay? So before I was plotting this this exponential function here, now I redefined this exp function to only return 1 all the time, so now it just plots a straight line, okay? So same name, but Python takes the one that's nearest to where it's executing. Yes?
If, for example, you had that situation, but if you do put math dot,
yeah,
then it would look for the...
Yeah, it would, but this wouldn't work because you never actually imported math, you only imported exp, so you would have to say something like this. Oops. Yeah. Okay, little style tip. When you're importing stuff, typically the order is anything that's standard Python, so that you never installed, that comes pre-installed for you, you import first. So things like OS, random, sys. I'll talk more about what these things do, but basically these are called standard libraries, so they're there for you. Things that you install from third parties, you put a space and then you import your stuff. So things like matplotlib, numpy, you put after, and then you put another space, and then anything that you define yourself goes at the end, okay? just keeps your code organized. Questions? All right. So now we're going to talk about packages. All right. And if you understand modules, then packages is pretty straightforward. All right. Basically, a package is just a collection of modules. Okay. So pretty intuitive name. You're packaging up modules together. And modules are just Python files. So it's really just a little bundle, right? So you can think of it as a sort of Swiss Army knife that, you know, the Swiss Army knife helps you go camping, but it can help you do different things, to accomplish different tasks with regard to camping, okay? So we're going to make our own little Swiss Army knife here. So it's going to be a package that we're going to call myplotlib, okay? Instead of matplotlib, we're going to call it myplotlib. And we're going to use it to help us, you know, do three things that we commonly do. We're going to plot 1D plots, 2D plots, and 3D plots, okay? So a package typically looks like this. You can think of it as a folder in your computer where the folder name is the name of the package, okay? And then Python recognizes it as a package if it has this file inside of it, which is init.py, all right? And inside that package, you can have more, I guess, sub-packages, right? So this is a subfolder of myplotlib called plot1d. And again, I give it an init.py file. Okay? That's just the way Python recognizes that this is a package that you're going to be able to import. Okay? And then inside each sub-package, you can have then your modules. Okay? So these are going to be the things that actually contain the Python code that does what you want it to do. So we're going to have three sub-packages here, each that do a different type of thing. So this one does 1D plots, this one does 2D, and this one does 3D plots. And we're going to have, this one is going to have two modules, right? One that does line plots, one that does bar plots. This one's going to do scatter plots, and the 3D is going to do 3D scatter plots, okay? So I will show you how that looks just on the regular computer here. So we're inside this L23 folder, right? This is the notebook we're running. This is that module that we wrote that just does simple plots. And this is a package, okay? So package is a folder. Inside there, you have your init file, which is usually left empty. It's kind of just like a signaler, but you can put stuff in there if you want to, but it's not recommended. And then you have your sub-packages, okay? Which also have their own init files. And then you have your modules, right? Which is just your .py files. Okay? So it's just a way to organize modules in a nice bundle. Okay? So let's take a look at what these actually look like. Sorry. Okay, so we're going to open it. So I'm already here, so I'll open, for example, the 1D plotting file, okay? It looks just like a normal module, right? Because it's just a normal module. It just happens to be inside of a package, all right? So what this does, I'm importing NumPy, I'm importing matplotlib, and I'm just defining a function that does a bar plot, okay? It takes as input a list of values, and it just calls the plotting function bar. It gives it the positions of the x positions of your y values, and then you put in your y values, the height of the bar. Okay, very simple. Again, here I was doing some testing, so I wanted to make sure that this works. So I was calling the function, printing. This will only get executed if I execute this file directly, but if I import it from somewhere else, this won't get executed because the name attribute will be different. It'll be something else other than main. Okay. And that's just what all these files look like, right? I can open, for example, the 2D plot here. This does a scatter plot, okay? Again, I was testing down here, but really when you import, you're going to only run this, okay? So this just calls the scatter function from matplotlib. So now I can import it kind of in the same way as we were importing modules, except you have to specify some sort of hierarchy, right? Because this is in a hierarchy. So I can say, let's say I want to make a line plot. I would say, all right, this is my package name. So I want you to look in this package. Again, it follows that list of places to look for that package. So if it's in your current directory, it'll find it. or if it's in one of those other preset directories, it'll find it. And then I just say, all right, I'm going to access an attribute of this, and it's going to be the plot1d package, right? And from there, I'm going to import the line module, okay? So now I've taken a module out of a package, and I can use it. So now I can say module name dot module attribute, and it'll make a line plot, okay? So it just went, you know, it went in here, it looked for this, you told me to import to go in here, and then it found this, okay? Is that clear? If I wanted to do a 2D plot, I would just look in, you know, in my plotting package, in the sub-package plot 2D, and then that's going to have a module called plot2d. And again, I can go on that module, call its attribute, why is it like this? Yeah. Call its attribute myScatter. Why? That's weird. Oh yeah. All right, I'm gonna do it like this. No. So my module name is, oh yeah, from. So from the package name, myplotlib dot plot2d import scatter, right? Which is the name of this file, scatter. Okay. So now I'll have scatter, and it'll make a scatter plot, okay, based on these, the x coordinates and the y coordinates I gave it, right? So this is a 2D thing. If I want to do something cooler too, I can make a 3D plot. So again, this is just extra stuff, but what I'm doing here is I'm saying I'm going to look at my package, I'm going to give my sub-package and then my module name, I'm going to import it, and then I'm just doing some extra stuff here, but at the end of the day, I'm just giving x, y, and z coordinates to my scatter, to the function my3dscatter, which is defined inside the module scatter3d, and they should make a 3D plot. Yeah, so something like that. All right? Yeah, okay. Questions there? So really a package is just a bunch of modules placed in a sort of like file system way, right? So you have to specify which sub-folder your module is in, and then you can use it like a normal module. All right. So one of the really nice things about Python is that tons of people use it, and tons of people are writing really useful pieces of code and making them public. All right. So anybody can say, okay, look, I wrote this package, like the one we just wrote, and I'll email it to you, and then you can paste it into your computer, and then you can start using it, right? Obviously, this is a little bit annoying, right? You'd have to be in touch with everyone and then go into your folder and drag and drop or whatever. So basically, Python gives you a tool called pip, and Anaconda, which is what we've been using, gives you another tool called Conda, but they do essentially the same thing. And what they do is they let you really conveniently install other people's packages so that you can start using them really, really quickly. So basically, these are command line tools. The one called pip, what it does is it searches on this website here called the Python package index that contains thousands of packages that people have written. Here it has, okay, so 120,000 packages are in here. That's a lot. So basically, in one shot, it'll be able to download the package for you and put it in the right place so that you can start using it right away. Anaconda has a similar one that's just more specialized to scientific packages. Typically, if you don't find something in the Anaconda one, you'll find it in pip. So basically, it's really simple. All you say is, on your terminal, you say pip. You're going to call the pip executable. You're going to tell it that you want to install something, and then you give it the name of a package. And then what it does is it goes online, it tries to look for that package, downloads that folder, like the one we made, myplotlib, and puts it in the right subfolder for you. All right, so we can try doing this actually. What does this do? I don't know. Okay, so this one is a Sudoku puzzle solver. All right, seems cool. So all I have to do is give its name. All right, so it's called Kaidoku. So I go on my terminal, and I say pip install Kaidoku. All right. So it's downloading, right? Seems to have found it. Okay, it's pretty big. Oh no, all right. Right, so that's just taking, it's probably a really big package, so it's just a folder on a computer, downloads it, and it places it in a directory, right? It says stored in this directory. Well, not exactly that, but basically it's one of those folders that Python looks for packages in, right? So now if I run Python, I should be able to say import Kaidoku, if that's how you use it. Yeah, so I can import it. I can say help Kaidoku, and it'll give me a little string. Okay, I guess these are the modules that I can use, and all that. Okay. So conda is the same thing. You just say conda install, and you'd have to find like the modules. For example, a really popular one is Seaborn. That helps you with plotting. I think I already have this installed, but it's the same syntax. It goes online. It's just a server that has all these packages. It'll download them for you, stick them in the right place, and then you can just import them normally. Okay. So I think that's all I have. I just wanted to say something about the assignment really quick. You probably know how to do this, but on the website it says that you have to download this file, full.py, which is a module that I wrote, and I want you to import it in your code. Okay. So all you have to do is like copy paste this into a file in Sublime or wherever you want, save it, and save it in the same folder that your notebook is in that you're working on, and then you'll be able to import it. Okay? Hopefully you understand how that works now. And that's all. Have a nice weekend, guys.